Hi, I'm Kelsey Brennan-Wessels, and welcome to this special edition of Earth from Space. And today we're focusing on climate change. Observation satellites have been orbiting Earth for over 30 years, and the long-term data they provide have enabled scientists to gain an even clearer picture of the changes happening to our planet. The Intergovernmental Panel on Climate Change, or the IPCC, is a scientific body dedicated to reviewing and assessing the causes and effects of these changes. Now, I'm here today with two coordinating authors of the IPCC's assessment report. We have David Vaughan from the British Antarctic Survey, and we have Albert Klein from the Royal Netherlands Meteorological Institute. Thank you so much for joining us today.
It's a pleasure.
Hello.
Now, David, I understand that you focus mostly on the cryosphere. We're talking about glaciers, ice sheets, for example, while Albert, you focus more on climate change related to the atmosphere and just surfaces. Can you tell me a bit about the changes you've seen in these areas? David, let's start with you.
We've seen changes in almost every aspect of the cryosphere. Sea ice that forms over the Arctic, the North Pole every summer, has been diminishing now for around 30 years. In the last few decades, it's shown very strong rates of loss. We've seen glaciers around the world are diminishing now. In the last assessment that we've just produced, we can see that almost every region of the Earth where there are glaciers, they are diminishing. The only one area where we're still a little uncertain is New Zealand, but it's really just down to that final piece in the jigsaw. We see snow cover being reduced over the northern hemisphere, and we see the ice sheets on Greenland and Antarctica. Both are year by year getting smaller, adding water back into the oceans and creating sea level rise.
Okay, and that was looking at the cryosphere. Now, Albert, how about in your areas?
Yeah, the observations tell us that the warming of the Earth continues, and each of the last 3 decades was warmer than the previous decade. And also, if you look at the longer term over the last 150 years, you clearly see in the temperature observations, both on the land and the ocean, that warming continues.
Okay, now how do you use satellite data in your area of study?
Well, for many places we have in situ observations, so at stations, at the land for instance, but also we use satellites where we don't have any information for more traditional observations. Particularly looking at the atmosphere higher up in the air, and that's really where the satellites come in and are really mostly the most important source of information.
Okay, and David, how about in the cryosphere? How do you use satellite data?
We use satellite data in almost every aspect, monitoring sea ice and snow cover. Monitoring the ice sheets is actually a little bit more difficult, but we now have, and this has been developed now in the last 7 or 8 years, different techniques for measuring how much ice exists in the ice sheets. And how that's changing. We can essentially weigh the ice sheets without the gravity satellites like GRACE. We can measure the thickness change of the ice sheets using altimeters on ERS-1, ESA space satellites, and on similar satellites like ICESat, which is an American satellite. Mm-hmm. So we can monitor not only the regional patterns of ice loss, but also the temporal patterns, whether the ice is being lost in the summer due to changes in snowfall or surface melt, or whether it's changing in the winter because the glaciers that drain the ice sheet are flowing at different speeds.
Okay. Now, how can this information help us prepare for the future, or can it help us prepare for the future?
One of the things we really need to know about the future is the rate of sea level rise. There is the likelihood that sea level will rise somewhere between, let's say, 0.5 metre and 1 metre in the next 80 or 90 years to 2100. That's the difference between 0.5 metre and 1 metre is a huge impact on the frequency of coastal flooding to areas of vulnerable coast, and that might be the Netherlands or London or many areas in Europe and further afield. And we need to understand just how much sea level rise we will get if we are going to prepare for the future, improve our sea defences and manage our coastal land in a way that will actually prove it sustainable.
Okay, Albert, would you like to add anything to that?
Yes, the observations clearly help us to improve the models that we use to make these predictions. For instance, if we look at temperature, the changes we see now, the warming, we expect that they continue, or we project that they continue into the future. But with how much is really essential also for our adaptation policy and adaptation measures. And I think that's where the observations come in to help improve the models. It's, by the way, not only the temperature changes that we see in the observations, it's also changes in precipitation and other parts of the hydrological cycle. And it's also changes in extremes, which are very important for impacts and for society.
So it's really important we get the whole big picture view.
Yeah, we get the whole big picture, and satellites are crucial for improving the whole big picture.
Okay, great. Well, Albert and David, thank you so much for joining us today.
You're welcome.
And to our viewers, remember that to learn more about climate change, Earth observing satellites, or about space activities, you can visit our website at www.esa.int.